Hello everyone and welcome to this next step on the WYSIBot. For this step we're going to be adding sensor calibration to the robot. So up to now you've done the previous 5 steps where we've added the actual line sensing and the drop sensing. What you probably noticed though is it can be a little bit unreliable, okay? And so what we're going to actually add in is a little bit of what we call sensor calibration. We're going to calibrate the sensors and then we're going to use those calibrations to make sure that it can follow the lines and detect the drops for your robot. Now this is actually the step 3 in the whole process. On the now room, you've got step 1 and step 2. We're going to add in a 4-pin connector in step number 1. In fact, we're going to add in 3 4-pin connectors just so that we've got it all set up. So follow those instructions on the now room. Go to step 2 where you're going to wire up an OLED display, which is like a little display. Again, those instructions are on the now room. Just get the basics of it going. We'll come back to the OLED displays in the future. And once you have all that working, come here to step number 3 and have a look at calibrating these line sensors. Now, in order to actually get the robot functioning correctly, we really ideally need to calibrate the sensors. Okay, up to now, with the current implementation, it just assumes a percentage drop in the reflectance of each of those sensors. Now, this works for the most part, but it can be inaccurate. There can be variations in the actual sensors themselves, so the components. So the LED is not as bright, maybe the phototransistor is not as receptive. Okay, and in some cases it could simply be that the LED and the phototransistor are just pointing slightly away from each other on the left sensor and slightly towards each other on the right sensor, and it just creates slight different readings coming off those sensors. We can also get background interference, so you get like lights and things like that. Sunlight can add a little bit of extra light into it and things like that, so it can depend upon your environment and things like that. And then we also have the variations in the actual table surfaces and the actual tape that we actually use it itself. Okay, so we're using black electrical tape. You might get slightly shiny electrical tape. You might get sort of more matte type tape. And then your table surface might be quite dirty or something like that. So it can actually change how reflectance the actual table surface is, as well as that black tape. So the calibration is quite useful because if we do take a calibration from the actual sensors, and what we do is we take some actual readings off those sensors, we can then accommodate for those variations. So we can accommodate for the variations in the sensors simply because we're taking readings off each individual sensor and remembering what its readings were, and then using those as our baseline. And then it can also obviously make variations for the environment, so we can rerun that calibration if we change our environment, or we can rerun that calibration if we change the tape that we're using, or if we change the surface of the desk. Okay, so it just allows a bit of adaptability instead of having to rely on those percentages, which can be quite unreliable. And some of you may have noticed that your robots miss the line occasionally and just keep driving off. Now, once we've done the calibration, we're then going to save that into the EEPROM alongside those motor calibration settings that we had before. And those calibrations we can then pull out into our code on the next step of this, where we can then code it in, pull those sensor set readings out, and actually use those readings in order to improve the reliability of the robot. Now the calibration process is all in the now document, okay? So follow that very carefully. Okay, what you're gonna have to do is download the calibration code. I'm gonna give you that code. Okay, so download that code, upload that to your WYSIBot. Your WYSIBot won't do anything, but if you've got the OLED display in there, you should see step 1 appear on the screen. Now, once you have all that set up, what we're going to do is going to open up the serial plotter to allow us to visualize the data that's coming off the sensors. That will just help us when it comes to positioning the actual robot. All right, so take a piece of black tape, stick it on the desk in front of you. It only needs to be a short piece, just enough for us to place the sensors over. And what we're going to do in step number 1, we're going to place the left sensor on top of the line with the robot sat flat on the desk. And you should see on the serial plotter that the line goes down when you place the sensor directly over that taped line. Okay, now what we're then going to do is press button B1 and it will move to step number 2. It's going to commit that little reading from the left sensor into memory. We're then going to do the same for the right sensor, so you're going to slide the robot over so the right sensor is now over the taped line. Again, the serial plotter will show you the right line now, okay, and we should be able to see that dip on the sensor. And when we do that, we press button B1 again. That's going to commit that right sensor's line calibration into memory. And then for the final step, you're just going to lift the robot up, making sure nothing is underneath the sensors and at least sort of 10 to 20 centimeters from the surface of the desk. You should see 2 lines appearing on the serial monitor. And what you should then be able to do is press the button just to calibrate the drop sensing. So it's also going to remember the values for what it should see for a drop. Okay, and then what it's going to do once you've done that final step, it will say finished on the screen, and it's going to write that into the EEPROM for us. So everything will then be saved on the Arduino, ready for the next steps. If you ever need to recalibrate, if you ever change your environment, change your tape, or if you change your sensors, you can simply come back, upload this code again, and rerun that calibration process. Okay. In the next step then, I want you to have a look on the now room. What we're going to do is use the code from the previous session, where we got the drop sensing in there from step number 5. What you're going to do is you're going to modify that code so that we can load the new settings from the EEPROM. We're also going to add, just for convenience, a little stop button on button B2 so that you can start and stop the robot. And then we're going to modify the actual code, the actual sensing code for both the drop and the line sensing, to use these new calibrations that we've just saved from our robot into the EEPROM. Now, hopefully, once we've finished that step, when we run the robot, it should be much more reliable, much more accurate when it comes to following the line. Follow those steps and see how you get on.